So quadratic equations are the simplest forms of inequalities that you are going to see in calculus course. We will do more complicated inequalities here, but let's start with quadratic ones. So just simple parabolas. If you have inequality in this form with complete squares, you can take the square roots. So you don't need to open the parentheses and do quadratic equation things, but there is one catch that you have to be very careful about this. So 2x minus 5 squared is less than 1 means that when you take the square roots, 2x minus 5 has to be less than 1. Square root of 1 is 1, right? However, this square at the same time puts a restriction on the other side of the interval. So since remember that when we were solving x squared is equal to 1 in equation, the solution was plus minus 1. So this puts restriction on the other side, which says 2x minus 5 has to be greater than negative 1 and less than 1. So a number greater than negative 1 is a number between negative 1. It's like negative point something. So that's when you take the square of that, the negative sign will get eliminated and you will still have a number whose square is less than 1. So you have to be careful about the other side of the inequality. Now add 5 to all three sides and then get that 4 is less than 2x less than 6 and divide by 2. So that's 2x3. So x is between 2 and 3, or you can write this solution as 2, 3. If the question is not in quadratic form, you can still solve it using parabolas. You can draw the graph of this equation or find the roots, and by investigating its parabola, its graph, you can say whether it's positive or negative. So here, if you find the roots, you can factorize this as x minus 1 and x minus 2 less than 0. Or the roots of this equation are going to be x1 is 1, x2 is 2. So if you draw the graph, so it's not very accurate. So the roots are here 1 and 2. Since the leading coefficient is positive, the graph of this equation is going to be upwards parabola, a parabola looking upwards, and we want it to be negative. So negative means everything that is below this x-axis, below here. So this part is negative, so that means the x has to be between 1 and 2. So that these numbers, a number between 1 and 2, makes this parabola negative. So we also have this equality sign, so we can capture these roots of the quadratic function. So the solution set of this quadratic inequality is actually going to be between 1 and 2 and including 1 and 2, so closed interval 1 to 2. So this example is to show you something that you should not do. So you can't say that it's like you can't solve it like this and divide both sides by x and get x is less than 7. So this is not the complete solution of the inequality. So this is not correct. So you have to treat this as quadratic equation and take this x out of the parentheses greater than 0. Now it has two roots. x1 is 0, x2 is 7. So if you plot the graph of this equation, if you plot the graph of this quadratic function, the roots are 0 and 7. The leading coefficient is negative. The coefficient in front of x squared is negative, so that would be a parabola facing downwards. And we want the parabola to be positive. We are looking for the positive part, and it could be equal to 0. So the result, the solution set of this inequality is closed set from 0 to 7. So this type of linear fractional inequalities are exactly same as quadratic inequalities. So if you solve this x minus 5 multiplied by x minus 3 greater than 0 inequality, you'll get the same answer with only one difference. this function cannot be equal to 3 because if it's 3 you would be dividing by 0, but this one could be equal to 3. So in this one we are excluding x is equal to 3. These are completely different functions, but when it's inequality they will give you same result. So let's solve this one. So x1 is 5, x2 is 3. So if you draw the parabola, the roots are 3 and 5. If you open the parentheses, it's upwards parabola, so the graph is going to be upwards. And we are looking for positive results, so the part which is above the x-axis is here. So the first part, and so x is going to be from negative infinity up to 3, so this part. But we are not including 3 because our original inequality says that we want to be dividing by x minus 3, so x cannot be equal to 3. We exclude 3, but we can include 5. So if I plug 5, it will be 5 over 0 over 2, so that gives me a 0. So 5 including to positive infinity. So that is the solution set of this inequality. The only difference between the solution set of this inequality and this inequality would be this sign. If you are solving the quadratic inequality, instead of this open parenthesis, you would have put this closed parenthesis, because in this inequality you can say x is equal to 3, but here not. Sometimes quadratic equations will not have roots. So when quadratic function does not have roots, it means the graph is completely above x-axis or completely below x-axis. Depending on whether it's positive or negative, the solution set of the quadratic inequality will be all real numbers or nothing. So in this case, so if you do the discriminant of this quadratic function, which is b squared minus 4ac, so 4 squared minus 4 times 7 times 1, which is 16 minus 28, which is obviously negative number. So this equation has no roots, which means depending when you draw the graph of this, since the leading coefficient is positive, it's an upwards facing parabola, and upwards facing parabola could be somewhere here, and it's completely above the x-axis, so it's always positive. So the solution set of x is going to be R, all real numbers.